Hello everybody, have a nice day today. So I think you are enjoying the video classes and it is my sincere request to watch carefully, sincerely, note down what are the different teachers are teaching and do the assignment. Okay, dear students, today we will start a new chapter and the name of this chapter is written there, that is three-dimensional geometry and popularly it is called 3D. It's just like AOD, application of derivative, similarly it is three-dimensional geometry and popularly all the students and all the teachers know it is the 3D. When the word 3D is coming, you know in the standard 11. Just you recall, three-dimensional geometry. When three perpendicular lines intersect each other, if the three lines are perpendicular to each other, just I am showing here, this is a line, this is a line and this is a line. So it divides the space into 8 parts, and though it is 8 parts, that is called octant, that you know in the standard 11. So in 3D we will tell about the octant, but in the 2D where the straight line you refer or your geometry, your coordinate geometry, that was the 2D. So there 4 quadrants, because the two lines perpendicular to each other divides a plane into 4 parts. So each part called is quadrant. Similarly, if the 3 lines, that means one is x-axis, y-axis and z-axis, if they are intersecting each other at orthogonally, then the space is divided into 8 parts and each part is called the octant, that you know. So the knowledge of the octant is required here, and specifically knowledge of the vector is required here. Just before the vector chapter is over, and because this chapter will understand very clearly if you understand the concept of the vectors very clearly. So just I am reminding what we have done in case of vector chapter. Okay, so one by one you see, I am showing the slides before you, one by one you see. So that is called we are talking about the previous knowledge. What is the knowledge required to come to the chapter? That is called previous knowledge. So in previous knowledge, I am taking about the vector. First about the vector. You just recall what you know in case of vector. We know what is called a vector, and vector we are writing generally a vector, suppose a1i plus a2j plus a3k. So a1, a2, a3 are the coefficient of ijk. So you see the screen, what is written there? The magnitude of a vector. The magnitude of vector is a mod, that is a1 square, a2 square, a3 square root over. That you know the magnitude of the vector. As you know, vector is a quantity having magnitude and a direction. And simultaneously we know what is called the unit vector. Unit vector is the vector having magnitude 1. Suppose n cap, n is a vector, n cap is denoted as a unit vector. So let n vector is equal to a vector, then a modulus is equal to 1, then we will say that vector is the unit vector. So unit vector how we are getting? suppose unit vector of vector A, that is A vector divided by its magnitude. If the magnitude is divided, so automatically the magnitude becoming 1. Addition and subtraction of the vectors we know. We know the addition and subtraction vectors, how the 2 vectors are added or 3 vectors are added or 2 vectors are subtracted. That is the operation of the vectors, that you know. Position vector. Position vector means nothing. It is represents the coordinate of a point in 3D. That is the vector which represents the position of a point on 3D, in 3-dimensional geometry, on space I can say, that is called the position vector. So, I can say it is a vector where the initial point is origin, and already written there you see, let A be a point with coordinates x1, y1, z1. If the vector name will be OA vector, where O is the origin, then OA is not a vector. It is the position vector, because the initial point is the origin. One of the point is origin, so this is called the position vector. So, I can write OA vector is equal to x1i plus x2j plus x3k. Similarly, if the coordinates of the 2 points are given, suppose point A having coordinate x1, y1, z1. Similarly, point B having coordinate x2, y2, z2. So, what is the name of this AB vector? So, how this AB vector is represent? If you use the triangle sum property, I am not describing details. So, AB vector will be, just you recall, x2 minus x1 whole into I cap plus y2 minus y1 whole into j cap plus z2 minus z1 whole into k cap, where I, j, k are the unit vectors along x axis, y axis and z axis, that already you know this thing. Then we should have the knowledge about dot product and cross product. Dot product already you know. I am just reminding what you know. The dot product of the two vectors A and B denoted by A dot B is equal to A magnitude B magnitude cos theta, where theta is the angle between the vector A and vector B. That is the dot product. And from the dot product we can say angle between the two vectors. That is the very important point in lieu of or to study the 3-dimensional geometry. That is, if the theta is the angle between two vectors A vectors and B vectors, then cos theta is equal to A dot B divided by A magnitude into B magnitude. And simultaneously I can say, if the two vectors are perpendicular to each other, then the angle between them will be 90 degree and cos 90 is equal to 0. So, if A vector perpendicular to B vector, that implies that A dot B is equal to 0. If the two vectors are perpendicular to each other, so their dot product is 0. That you know about the dot product. So, many other properties are there. I am not discussing details, because whatever required for this 3-dimensional geometry, that I am talking about. Similarly, if A vector is parallel to B vector, then A vector is equal to lambda times of B vector. That also you know. This is very important one. A vector parallel to B vector, then one vector is the scalar multiple of other. That is, A vector is equal to lambda B vector. Then come to the cross product. You know, The cross product of the two vectors A vector and B vector denoted by A cross B is equal to A magnitude, B magnitude, sin theta into n cap. That n cap is very important. You should understand what is n cap. Now this is the direction. This is the direction perpendicular to the plane containing the vector A vector and B vector. Means its direction is perpendicular to the vector or to the plane containing A vector and a B vector. And you know A cross B is not equal to B cross A. If the A cross B direction is going, suppose upward, then the B cross A, the direction will go downward. So A cross B not equal to B cross A, rather A cross B is equal to minus B cross A. That you know in case of cross product of the two vectors. And as you know, if A vector is parallel to B vector, parallel means the angle between them is 0. Though in case of your cross product of sin theta is there, so sin 0 will be 0. So in this case, A cross B will be 0 if A vector is parallel to B vector. Okay? Then what you seen in the last you have seen STP. STP. That STP is scalar triple product. It is a scalar, means the output is scalar, and is a triple, means taking 3, and it is a product. The scalar triple product of any three vectors A vector, B vector, C vector is A cross B dot C or A dot B cross C, and denoted by like this. Your bracket is given A vector, B vector, C vector, that is the scalar triple product. Dear students, you just see A cross B dot C. A cross B dot C or A dot B cross C, that is called scalar triple product. Obviously, because you see, if you will do this say solution, A cross B is a vector. This vector will be dot with C vector. So suppose A cross B is X vector. So X vector dot C vector is equal to 0, means X dot C must be a scalar. So the output is a scalar. So that's why it is called the scalar triple product. It is a very important point here. If the scalar triple product of the three vectors is 0, then the three vectors are called coplanar. Means they are lying on a plane. They are lying on a plane and they are called the coplanar. That I want to show you here how at the vice versa occurs also. If the STP is 0, then the three vectors are scalar. If the three vectors are scalar, then the STP is also 0. So these are the things that we have seen in the PPT. So now we will discuss from the beginning, say what is the necessity of reading this chapter, that is three-dimensional geometry, and what are their insights. What are there inside this chapter? So inside the chapters, what we will discuss particularly, note down. Note down please. First we will see direction, cosine or direction ratio. This is a new word for you. Then you will go to say straight line. The equation of the straight line, we will see the equation of the straight line. Then we will go to the plane, plane. Then we will discuss about the plane and straight line or point of intersection. Point of intersection of plane and a line. Then we will discuss coplanarity. Coplanarity of coplanarity. The condition of the coplanarity. And in the miscellaneous we will see many cases. So these are the main division of the chapter. This is the main division of the chapter. Okay. So let us see one by one. I am showing you the first point what I have discussed. The three vectors are coplanar. The three vectors are coplanar. Look at here. Suppose it is a plane. The surface of the table is a plane. I have taken one vector. Suppose it is one vector. This is one vector. And this is another vector. And suppose you consider the pen is a vector. All the three vectors having different color. I want to show you if the three vectors are coplanar, how the STP, scalar triple product, is coming 0. Suppose we will do the cross product of these two. This vector, the red and the green vector cross product. So the direction will be like this. So what this represent? And this represent A cross B. So A cross B is what to the plane? Perpendicular. So the A cross B is what to the vector or what to the third vector? Perpendicular. So if you do the dot product of this and this vector, so what is the name of this vector? The name of the vector is A cross B. And what is the name of the vector? The name of the vector is C vector. So if you do this dot product, then what I will write? A cross B within bracket dot C should be equal to 0 as this vector and this vector are perpendicular to each other. So my point is to say, suppose, what is the definition of the coplanarity of the three vectors? Coplanarity of the three vectors is if the three vectors are lying on the same plane or the parallel plane. So let us discuss, let they are lying on the parallel plane. So I am taking these two vectors in this plane and you see this is a vector parallel to the surface of the table. I am taking another vector here. So now this vector and this vector also coplanar. And again you do the cross product of these two. So A cross B, the direction will be perpendicular to this vector. And though this plane and this plane both are parallel, so this vector will be perpendicular to this vector. Perpendicular to this plane. And on this plane one vector is there. So this one, what is the name of this? The name of this is A cross B. Because they were on the table, they make the A cross B cross product among them. So I am showing the direction. Direction is coming perpendicular to it. And this vector means this S cross B is perpendicular to the plane. And on the plane another vector is C vector. So this one is perpendicular to the C vector. If you do the cross product, dot product of this and this vector lying on the another plane named as C vector, so it will be A cross B dot C. And though this vector and this vector are perpendicular to each other, that dot product will be 0. So what will get? Now A cross B dot C is equal to 0. That is A cross B dot C. The other name is STP. So I have shown you that if the three vectors are coplanar, either they are lying on the same plane or they are lying on the parallel planes. If the STP is coming 0, so they are coplanarity, or if they are coplanar, their STP will be 0. So that is one of the experiment I have shown. Okay. Before going to this chapter, I must tell you that the imagination is required. So how you are seeing the sweet dreams in your sleeping, in this way, by closing the eyes, you have to realize, you have to imagine what is the situation happening. Okay. Anyway, so in this chapter, I will take this room as one of the octants, and this is the origin, this point is origin, and throughout this chapter, this will be your x-axis. Remember, and this will be your y-axis, and that will be your z-axis. Correct? Imagine this will be your x-axis I have taken, and this is the y-axis where the green board is there. This is the z-axis, and this is the origin. In the back side of the x-axis, the x-axis is extended, and here also y-axis is extended, and here is the z-axis is also extended in the downwards. Imagine yourself, we are in one of the octants. Suppose I am in the 5 stair of a apartment. So in this apartment, this is the one of the axis, and beside that, in the back of that, the axis must be extended because another room must be there. And similarly, there also another room is there. And here in the down, in the below this floor, another room is there. You just see 8 rooms, and where this is the x-axis, this is y-axis, this is z-axis. Imagine 8 rooms are there in the 4th floor, or in the 5th floor, 8 adjacent rooms are there. 8 adjacent rooms are there, which all the rooms having the origin this one. Correct? So my first topic, my first point about direction cosine and direction ratio. This is the very important concept in 3-dimensional geometry. If you are not able to understand this direction cosine and direction ratio, then I think you will not enter inside the chapter. So once again I am telling, to enter inside the chapter, highest one is imagination. You have to imagine. The knowledge of the vector is adequately required. Then the third requirement is, I told the first concept, that is direction cosine and direction ratio. Then the first question, why you will read this one? Why we will read? Why we will read? That is direction cosine, the shortcut it is written as DRC. Direction ratio we are writing DRS. So my question to you, if you know anyone, why you will read DRC or DRS? Dear students, you just remember how you are finding the equation of a line in plane. Equation of the line in plane. Suppose you look at here. This is a line and this is the plane. And to find out the equation of the line, what was the requirement? Suppose this is the x-axis and this is the y-axis. This is x and this is y. And we are going to find the equation of the line. So what was the requirement? The requirement is slope. What is the slope? The angle made by the line with the positive x-axis, that is the slope angle. So this is the slope angle theta. And what is required? Now through which point the line is passes? Let the line is passes 2, 1. Once again, how you are getting the equation of the line in plane? Two requirements. You will tell about the standard form. Two requirement: passing through a point and must have the slope. What is the meaning of slope? The slope is the angle made by the line with the positive x-axis. Then why we are doing like this? Because if you take this parameter and this parameter, the line cannot change its position. If the line will change its position, then you cannot find the equation. Let us come to this. Let us come to here. The line is coming to the space, and with the slope angle and passing through the point, let us see whether you are going to stable the line or not. If you are able to stable, then you can find its equation. If you are not able to stable, then you cannot find out the equation. Suppose I am taking this one. The line is there. This is the x-axis already I told. Look at here. Let this is the angle. This is the angle made by the x-axis with the line. That is your slope angle. Let the line is passing through the point where I am putting the chalk mark. Let the line is passing through this point and making angle theta with x-axis. Means what we have done in case of the line on 2D on the plane, that I am taking to the space with the same data. What are the data? Angle made by the line with the x-axis and passing through a point. Look at my position. So if I do like this, the angle will remain same. If I do like this, the angle will remain same, but the position is changing. Suppose I am taking out this. Look at here. This is the point. It is passing through the point and making some angle with x-axis. So if I will change the position also little, the angle is remaining same and the point, I am rotating on here. I am rotating the line about this point. You look at here. The point is remaining same and the angle is remaining same, but the position of the line is not fixed. Once again, the line is passing through a point. The point is fixed because I am constant. And the angle is theta with positive x-axis. What are required in case of plane? But you see, by getting these two also, the position of the line is not stable. It is not fixed. Look at here. You see, the angle is remaining same, angle is remaining same, angle is remaining same, and the point is remaining same, but we are not able to fix the line. So my dear students, this is the reason that why the slope is not working in case of space to find out the equation of a line. Then the question arises, how the line will be fixed its position? So one angle is not enough to fix this line. So I can take the help of like this. Suppose the line is like that. Suppose the line is like that. Let the line is making x axis some angle, y axis some angle, z axis some angle. Let the line is making alpha angle with x axis, beta with y axis, gamma with the z axis. If the three angles will consider, and again it will pass through a point. Three angles, x axis, angle is alpha, y axis, angle is beta, z axis, angle is gamma, and the line is passes through a point. Once again I am showing here a small cases. The small cases I am telling. Look at here. I think you are able to see. Let this is your x axis, y axis, and this is your z axis, and I am taking this line. Look at here. Let the line is passing through the point. I am showing the point there. Okay. X axis, this angle is alpha, y axis, this angle is beta, z axis, this angle is gamma, and a line is passing through the point x1, y1, z1. So, can you change the position of the line? If you take this one of the angle will be disturbed. If you take like this, one of the angle will be disturbed. If you take like this, angle will be disturbed and the point will be disturbed. So, my dear students, to find the equation of a straight line in space or to fix the position of a line in space, line or you can say it is a vector, we need the angles made by x axis, angle made by y axis, angle made by z axis. So, now you come to here. Suppose I am taking out all these things. Say I am taking x axis, say y axis, say z axis, origin. I have taken either a line or a vector. Let it makes angle alpha with x axis, angle beta with y axis, and angle gamma with the z axis. And the cosine of those angles. Now, why we will read DRC and DRS? We understood one angle cannot fix the position of a line in space. We need the three angles made by the coordinate axis. And cosine of those angles are called direction cosine. Cosine of the angles. Cosine of the angles are called direction cosine. Direction cosine. And denoted by DRC. So, now you understood why the direction cosine is required. So, I can write cos alpha, cos beta and cos gamma are the DRC. And in the shortcut, it is denoted by a symbol L. L is called cos alpha, M is called cos beta, and N is called cos gamma. And this LMN also denoted by L, N, N. So, the cosine of the angles are called the direction cosine. So, we are reading the direction cosine of a line or a vector, because we can tell it is also a vector. This suppose y, this is a vector, I can say it is O vector also, or I can say it is O, A line also. Then, here one question arises, whether it is coming to your mind or not. What is this question? The question is, when I measure the angle alpha, beta, gamma, at that time line was starting from the origin or the vector is starting from the origin. When we are finding the alpha, beta, gamma, the line or the vector is started from the origin. Then the question arises, is it necessary to find out the direction cosine of a line or a vector that it must be started from the origin? Means if it will be origin started, the angle is looking better. So, the answer is no, it is not necessary to start the line or vector from the origin to find out the direction cosine or direction ratio. Why? See, just you imagine, I am taking, this is the line in the space, and I want to find the direction cosine, the angle made by the x axis, y axis and z axis. And I am standing in one of the octants. I am standing in one of the octant. You close your eye and just imagine. Imagine one line which is parallel to it in another octant and may originate from the origin. Once again, I need a vector or a line in any one of the octants. Means rest the 7 octant, you just imagine, you must get one line or vector parallel to it and started from the origin. So the angle made by that line which is started from the origin and parallel to this must be the angle made by this line with x axis, y axis and z axis. So if I will keep also like this way, you will get a line which is parallel to this in one of the octants and started from the origin, making angle alpha, beta, gamma, and this angle also applicable for this. If you will like this, if you will do like this also, if you will do like this also, if you will do like this also, every position you can get a line parallel to it in one of the octant and started from the origin, and both this line will have the same angle made with the coordinate axis. So direction cosine I told about LMN. Okay, so we'll see. We got what is the direction cosine. So now you see how the direction cosine is related to. I am writing here direction cosine and a coordinate of a point. Coordinate of a point. So what is the heading? The direction cosine and the coordinate of a point in space. That means we are going to establish a relation between the LMN and the coordinate of a point. Look at here. Suppose I am doing here the coordinates. Say, let this is the x coordinate, I am taking it as y, you can take it z also, and its origin. And let it is a line or a vector, you can say, at the point is O. OA is a line or you can say vector. Let the coordinate of this point is x, y, z. Correct? This point coordinate is x, y, z. Now you drop a perpendicular to the x axis. Let it is B say. And this is the angle made by the line with the x axis, alpha say. You remember what we are going to do? We are going to establish a relation between the direction cosine, that is LMN, with the coordinate of a point on the space. Okay? Let us take OA is a suppose vector. So OA vector, let having the magnitude r, or we can say OA distance is r. Correct? Now in triangle OAB, so already this is r and this is your x coordinate of this point A. So let us find the cos alpha. In triangle OAB, what is cos alpha? Now cos alpha is base by hypotenuse, x by r. And the other name of the cos alpha is L. L is equal to x by r. So what I got here? I got x is equal to LR by the cross multiplication. Similarly, if you draw the perpendicular to y axis and z axis, we must get y is equal to MR and z is equal to NR. So now, in place of x, y, z, I can write LR, MR and NR. What is R? R is the magnitude of the vector or distance of the line. So, this is the relationship between the coordinate of a point, how it is related to direction cosine. So, now one interesting thing you already got. Let us see the students. So, how we'll get it? So, how we'll get the distance OA, that is distance OA, that will be your x square plus y square plus z square root over, or you will do the squaring also. OA square is equal to x square plus y square plus z square. Put the values. OA means r square, x is already LR, that is L square r square, y how much you got? MR, m square r square, n square r square. Then r square is equal to, taking r square common, L square plus m square plus n square. So I can cancel here r square positive number, cancelling. So what we are getting? 1 is equal to L square plus m square plus n square. My dear students, this is a very important rule. Means the relation between the direction cosine. What we are getting? L square plus m square plus n square is equal to 1. In other words, I can write, if alpha, beta, gamma are the angle made by a line in space with the coordinate axis, then I can write cos square alpha plus cos square beta plus cos square gamma is equal to 1. You remember this relation. You remember the relation. Simultaneously we got two things. What is that? The coordinate of a point in space, how it is related to direction cosine. And by doing this one, I got a relation among the direction cosine, that is L square plus m square plus n square is equal to 1, or cos square alpha plus cos square beta plus cos square gamma is equal to 1. One small question to you. Just to write down one more question. Let, I am writing the question here. Let alpha, beta, gamma are the angles made by a line, or I am telling vector, with the coordinate axis, then find sin square alpha plus sin square beta plus sin square gamma. Look at this question. That is the question. Let the question number 1. Let alpha, beta, gamma are the angle made by a line or vector with the coordinate axis. Then find the value of sin square alpha, sin square beta, sin square gamma. Very easy. You can got the answer from here directly. That is, we can write here in the solution part, we know that cos square alpha plus cos square gamma beta plus cos square gamma is equal to 1. That is L square plus m square plus n square is equal to 1. So in cos square I can write 1 minus sin square alpha, 1 minus sin square beta, and 1 minus sin square gamma is equal to 1. Now 1 plus 1 plus 1, 3. So 3, I am taking the right hand side 1 here, and I am taking all these things to this side. Sin square alpha plus sin square beta plus sine square gamma. So, what is the value I got? You come to here directly. I got sine square alpha plus sine square beta plus sine square gamma is equal to 2. So, remember these two, which will be helpful to you: cos square alpha, cos square beta, cos square gamma, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Sine square alpha, sine square plus sine square beta plus sine square gamma is equal to 2. So, this is the relationship, the direction cosine with the coordinates, and this is the relation between the direction cosines, that is L square plus M square plus N square is equal to 1. So, thank you students for your patience hearing. Already I told before starting the class, this chapter is purely imagination. So, when you are watching this video classes, please imagine yourself, and if possible bring 2 to 3 pens with you. The pen may not be working properly, but when I will show some activity, then you will do with me, and when you will do with me, then you will get the idea, and your imagination power will be increased. So, thank you very much. Goodbye.